P1 V1 equals P2 V2.
A sample of helium gas in a balloon is compressed from 4 liters to 2.5 liters at a constant temperature. If the pressure of the gas in the 4.0 liters volume is 210 kPa, then what will be the pressure at 2.5 liters? V1 is 4 liters. V2 is 2.5 liters. So we also know that P1 is 210 kPa.
We can either set up the equation and plug everything in, or we can rearrange it to find P2.
210 kPa times 4 liters divided by 2.5 liters. Get the iPhone. So at the calculator right there, we just plug the
So
equation
that's
in.
336 kPa.
Yeah.
So that's your answer.
So the main difference between Charles' law, which we're going to be talking about right now, and Boyle's law is that Boyle's law was talking about volume and pressure, and Charles' law is talking about volume and temperature and how things change.
Right, they look fairly similar, but you're dividing initially instead of multiplying.
Yeah, so the equation is going to look like V1 over T1 equals V2 over T2. And essentially what people like to do is just cross multiply. I mean, whatever you want to call it.
So you could also represent that as V1 T2 equals T1 V2.
A gas sample at 40 degrees Celsius occupies a volume of 2.32 liters.
2.32.
If the temperature is raised to 75 degrees Celsius, what will the volume be, assuming the pressure remains at STP, which we haven't worried about yet. So
We always assume it's at STP.
yeah,
So we have to convert Celsius to Kelvin,
yeah,
and
so
Kelvin always equals Celsius plus 273.
yeah. Now we have T1, T2, and V1. So we're just going to go ahead and plug those into the equation.
So that's T2.
So we're trying to find V2. And this is the way I think Noah and I both like to do it. Just rearrange it.
So you don't get confused, because you plug the numbers in, it can be kind of confusing sometimes.
Yeah, it's pretty simple.
T1 equals, let's see, 0.32 times 3 all over V2, which is what we're trying to find.
I think we actually did it. Yeah. Don't worry about that. So now we're going to teach you a Gay-Lussac's law.
Which is represented as P1 over T1 equals P2 over T2.
And like we said, cross multiply, so it could essentially be P1, T2 equals, I don't know if I'm outside the camera, but P2, T1. The pressure of a gas in a tank is 3.2 atoms. It's at a temperature of 22 degrees Celsius, so that's going to be T1.
And T2 is 60 degrees Celsius. So again, both those values have to be converted to Kelvin. This time we're doing it without rearranging it prior to solving it.
Equals 295 K. And what we're trying to find, we're going to call that X, because little math likes to use X. Yeah.
Yes.
Yeah. So 3.2 times 330, we want to get K in there. Do the X, I don't know if I just erased that.
That's 1065.6.
We're going to get some basic algebra in here and divide 295 from each side. And that's going to end up being a bunch.
3.612.
And that would be in pressure, so atoms.
ATM.
ATM. And that's the problem right there.
That's Gay-Lussac's law.
Yep.